Okay, so find, it says use the graph to answer these questions. So this is in rectangular form. And we want to convert it to, we're going to take it, that's in rectangular form, and eventually convert it to polar form. All right. So, rectangular form, what's the modulus? So if we graph this thing, 2 minus 2i, so it would be right here. Real, imaginary. And the modulus is simply the distance that it is from the origin. That's your modulus. Okay, well, you already got a way to, you have a formula for that. Okay, when something is in rectangular form, there's our formula for the modulus right there. A squared plus b squared, take the square root. All right. So this is simply going to be the modulus of this is equal to a squared plus, now the b does not include the I, it's just the coefficient. There's no I, because all you're doing is you're just using the Pythagorean theorem on this triangle. This is 2. The negative just means it's going downward. So this length right here really doesn't matter that it's -2. You could just put 2. But right, that's the length. And when you simplify that, that's 2√2. But normally you just leave it like that. So guys, as because we're getting close to the end of this lesson here, so if there's stuff that I'm doing and you're not sure of, that because you're going to need to know how to do it in order to do the exercises, stop me and ask. Don't sit there confused. All right, now the argument, guys, this is the angle of rotation. Angle of rotation, and it's always measured counterclockwise from the positive x-axis. All right, so on my drawing over here, real, imaginary. Okay, it's located right there. Now, here's the angle that we're looking for. It starts at the positive x, the real number axis, and it goes this way. That's theta. That is known as the argument. Okay, so how many degrees is that? Pardon me? A little louder? 315. How'd you get that?
Each area is 90 degrees, and then that looks like 45 degrees.
Yeah, it looks half. Yeah, so yeah, you could say that. How do you know that this is 45? Other than it looks it. Yeah.
Because it's 2 across and 2 down.
Yeah. Yeah.
Each lengths are the same.
So these two lengths are the same. So they're both the same length, and if two sides of a triangle are the same length, then this angle has to be 45. Doesn't have a choice. So yep, this angle of rotation then would be 360, take away 45, which is 315 degrees. Or in radians, if you look at your unit circle, that should be 7 pi over 4. 315. Right here. All right, so either one is okay. All right, now you can write it in polar form. So for an angle to be in polar form, it's going to look like this. That's polar form right there. Okay, so all we got to do is just fill in that information. Where'd you go? There you are. Okay. Okay, so we know r is 2 root 2, so that I drop that out. And I get z equals, okay, 2 root 2 cosine 315 degrees plus I sine 315 degrees. And the one here where it says, the next section we've already done, it says arguments can be measured in radians. Okay, so angles can be measured in radians, that's the same thing. This is just angles. So if we took this and converted it into radians, it would just be 7 pi over 4. which is 315 in radians. Now, if it's something that isn't on your unit circle, let's say that it was like, I don't know, let's say it was 305 degrees instead. And you needed to convert that into radians. Well, the way you convert it is 305 degrees x radians equals 180 degrees pi radians. And you just solve that proportion. Yikes. Oh, boy, you are. I tell you, I always tell the kids, lucky I didn't karate chop. You know, my. Yeah, I'm sorry.
I'm good at sneaking up. Would you be able to cover Emily Johnson's fifth hour?
Emily Johnson, where is her
She's
class?
C108 on the other side of this building.
C108.
I sent you and Carla an email because I want to bug you during the second hour.
It
but
doesn't matter.
I just need to mark it down.
Sure,
Thank you so much. And
Yeah.
there's a roster in there and everything.
sure. C108.
That's right.
Gotcha. Alrighty. You guys got to give me a heads up. I don't want to karate chop my boss. So next time, maybe a throat clearing. Or intruder.
Or a high mystery scene.
Intruder alert. Anything like that would be helpful. I'd appreciate it.
Yeah, next time someone walks in, I'll just say intruder alert.
Intruder alert. Or stranger danger. Stranger danger.
They'll never know.
Okay.
Really good.
Boy, I didn't even know he was there. Holy cow. Whew. Like a ninja. Yeah. I'm glad he wasn't an assassin. Okay.
I'm sure an assassin walk in the front door.
Okay.
An assassin would just walk in.
Well, it's pretty darn easy. Okay, your modulus is a 4. Your argument is 120. So then on this piece of polar graph paper, I go out to the 4th ring and 120 degrees. So right there, 1, 2, 3, 4. Whoops, wrong one. Right there. So like a radar screen is an example, is similar to polar coordinates, except the 0 is on the top of the screen. When when you see a radar screen, this is 0. And the angles are measured that direction. So if this was a radar screen, this would be, let's see, I got 15, how much are these? 15 degrees. So that would be 270. No, 330. Okay. But really, if you can even sketch it on a rectangular plot. I mean, we can all estimate where about 120 is. Okay. All right. Modulus 5. Argument pi over 4, which is like 45 degrees. So if I was just sketching it, And you can plot it just on a regular graph. This is 5, and that is 45 degrees. Pretty simple. Okay, on on polar paper, 1, 2, 3, 4, 5.
What's the plus I?
What is the plus I?
Yeah, is that the answer to that?
Okay, so this right here is just another way of writing a complex point. All right, so for example, what's this thing the same as? Okay, what's the cosine of pi over 4 if you look at your chart? So on your unit circle, what's the cosine of pi over 4? Look it up. And what is it? Do you know how to find it? Mia? No? Okay. So, go ahead.
Root 2 over 2.
Right. So here's pi over 4. Okay, the first coordinate is always the cosine, and the second coordinate is always the sine. So this phrase, cosine pi over 4, is another way of writing root 2 over 2. Okay? So, what the I part is, okay, let's see. Okay, this part right here, this problem is identical to 5 times, okay, the cosine of pi over 4 is root 2 over 2 plus I, and the sine of pi over 4 is also root 2 over 2. And if I multiplied that out, it would be 5 root 2 over 2 plus 5 root 2 over 2I. Yes? Can you get a senior for, okay, can you guys come back when we're, okay, modulus 3 and argument 190. And if I was doing it on this one, I'd go out 1, 2, 3 rings, and I'm going to eyeball where 190 is. That's 195. So what is this? 85, 190, 195. So, somewhere around there would be C. Okay, B was over here. A was here. So it's just another way of writing a number. Okay, now what the next part's doing is asking you to convert back the other way. So we're starting with polar, and we want to end up with rectangular. So when I'm done, I want this to be in rectangular form. Okay, well, it's really simple. It's exactly what I just did a couple of minutes ago. All right? Take these two values, use your unit circle, and figure out what's the cosine of 120 and what's the sine. So I'm going to look at the unit circle and get what these coordinates are. So I just go to 120. Where did my unit circle go? Okay, right here. Here's 120. Negative 1/2's my cosine. Positive root 3 over 2 is my sine. Okay, so I'm just going to replace those with those values. Okay, this was negative 1/2. And this one was root 3 over, what? Root 3 over 2. So to get this negative 1/2, you use the unit circle for the cosine of 120. Go to your unit circle, the y coordinate at 120. So if you forget, okay, the sine is the y coordinate at 120 degrees, and the cosine is the x coordinate at 120 degrees. So x comes before y in the alphabet, c comes before s in the alphabet. That's how I always kept them straight. X was the cosine and y was the sine, using the order of the alphabet. Okay, all right, so this, we got this. Do I need to slow down? Are we okay? Yeah? Other side of the room? We're good? All righty. All right, so I'm going to go to my, this is the x coordinate at pi over 4. And this one is the y coordinate at pi over 4. So that is root 2 over 2. This is like the one I did, the example I did for you, Mia. And this is root 2 over 2. Times 5. There's your answer. All right. So that's 3. Now what you have to do is you got to figure out what's the x coordinate at 190 degrees. And what's the y coordinate at 190? Well, 190 is not on your unit circle. Okay, so you're either using your phone or your calculator, Desmos. Right, so if I was using my phone, you have to be sure that you're in the right mode. Okay, so when you do this on your calculator, I'll show you what I mean. Okay, I'm going to do it on the graphing calculator. Okay, so here's where you got to be sure you're in the right mode. All right, so this angle was 190 degrees. So on my calculator, I press mode, and I use the arrows here, and I go down and I change it. Right now it's highlighted in radians, and I want to move that over and highlight degrees. Otherwise, I'm putting in the wrong angle. It's 190 degrees. Okay, so then I'm going to clear that, and now I just, to get the cosine, I go cosine 190. There's the cosine, and then I do the sine. Sine 190. Okay, now if you're using your phone, you go ahead and do the same thing and see if you're getting the correct values here. So we did this part on our calculator and that part on our calculator. Got that. Being sure that we were in degree mode. Okay, and then you just multiply those out. So let's see. I'm going to take that times 3. So this second part, 0.5209i. That's negative, so this is going to be a minus. And then the top one, 984.8 times 3. 29544. And there's our answer. So there it is on Desmos, and the way you change your units over here on in the settings to degrees. All right. Okay, now what we want to do is convert the other way. Okay, so this was rectangular to polar, or excuse me, this was polar to rectangular, and now you're going rectangular to polar. Okay, now you've already done this. All right, so here's what you do. We want to convert this to polar form. So in order for something to be in polar form, you got to know it's you got to know the radius, and you got to know the angle. Okay, so in order for it to be in polar form, we need to know these values. Cosine that plus I sine theta. Okay, so getting R is easy. That's just the modulus. All right, now when you're figuring out the angle, you have to do a little bit of thinking before you put it in your calculator. All right, if I plot this, this would be 1, 2, 3, 1, 2, 3, 4. All right, so it would be right here. And I already figured out that this length is 5. Okay, now I want to get this angle. All right, so when to get that angle, you do the, we know this is, let's say, 4, and we know that's 3. So you use the inverse of the tangent to get the argument. Okay, so my argument, or theta, is going to be the arctan of adjacent over hypotenuse. Okay, so your argument is really your y coordinate over your x coordinate. You know, or if we call these A and B like we've been doing, that's A and that's B, then this would be B over A. But you have to know what quadrant you're in, because the answer that your calculator gives you may not be the quadrant that you're in. Okay, so what I mean by that is, let me pause this for a second here.